All right, let's dive right into this explainer. If you've ever stopped to wonder exactly who is out there building the massive, complex digital infrastructure that powers literally everything we do online, well, you are in the perfect place. Today, we're demystifying the distinct but deeply connected worlds of the network engineer and the cloud engineer. We are going to break down their core responsibilities, the tools they're using every single day, and exactly how these two completely different disciplines are forced to collaborate in today's modern IT setups. Here is our roadmap for today. First up, we'll look at the two pillars of IT. Second, the network engineer's world. Third, the cloud engineer's domain. Fourth, the tools of the trade. And finally, uniting in hybrid cloud. Section 1. Two pillars of IT, the builders of the backend. Okay, think about this. Every single application you use, every stream you watch, every database you query, it all relies on a highly complex backend. But building and maintaining that backend requires two very different types of architects operating in vastly different realms. To really grasp the difference between these two roles, we have to look at the one technology that basically split the IT world right in half, and that's virtualization. This brilliant concept is the exact dividing line between our two engineers. It takes us from a world bounded by physical cables, hardware limitations, and localized data centers, and launches us into a realm of infinite virtual possibilities where processing power, storage, and networking are delivered purely as software over the internet. Section 2. The network engineer's world. The physical foundation. Let's start with the physical side. Think of network engineers as the literal city planners of our digital world. They are the ones laying down the physical roads, the highways, and the traffic lights that allow packets of data to actually travel across the globe. And without this physical foundation, the cloud literally cannot exist. To pull this off, they rely on a rigid, highly structured physical hierarchy, something like the famous Cisco three-layer model, just to ensure total stability. So you got your access layer down at the bottom where your actual devices connect. Then you move up to the distribution layer, which acts kind of like a localized traffic hub, routing data and applying policies. And finally, you hit the core layer. That's the massive, high-speed backbone designed to transport immense amounts of traffic as fast as physically possible. It is a world of pure hardware structured rigorously for maximum efficiency. Right at the heart of this physical infrastructure, the network engineer has to deeply master the difference between two critical pieces of hardware. First, you have a Layer 2 switch. These are incredibly fast, but they only forward MAC addresses within the exact same local network. It's basically like distributing mail within a single office building. A Layer 3 router, however, directs IP addresses between entirely different networks, connecting one office building to another across the world. Managing this delicate handoff between switching and routing, that is the absolute bread and butter of the network engineer. But here's the reality. Physical networks get congested. And let's face it, IPv4 addresses are finite. Because of this, engineers rely heavily on the mathematical magic of subnetting to logically chop a network into smaller, far more efficient pieces. By manipulating the subnet mask and using techniques like variable length subnet masking, they conserve IP addresses and drastically reduce unnecessary broadcast traffic. It is highly technical, deeply mathematical work that keeps the physical network from crashing under its own weight. There's a great quote from Netrix that hits the nail on the head here. They say troubleshooting is about predicting what can happen, determining the anomalies, and investigating why those anomalies happened. And to do this, network engineers spend their days utilizing highly specialized command line tools. When a connection drops, they don't have some magical web dashboard to look at. They're using tools like Ping to verify device connectivity, or the Cisco Discovery Protocol to pull information about neighbor routers and switches hop by hop. It is a gritty, investigative process of checking physical ports, analyzing Layer 3 paths, and figuring out exactly where the physical or logical link just snapped. Section 3. The cloud engineer's domain. The virtual superstructure. Now let's flip the script and look at the cloud engineer. Tracing the history, we can see how this role evolved directly out of the 1990s virtualization boom. We went all the way from the primitive ARPANET in 1969 to renting virtual private networks right up to today's modern era, where the National Institute of Standards and Technology formally defines cloud computing as a ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. The modern cloud engineer doesn't rack physical servers at all. They write scripts to provision thousands of virtual servers in a matter of seconds. Instead of configuring physical Cisco switches and routers, the cloud engineer operates within three primary service models. In Infrastructure as a Service, or IaaS, they manage virtual processing, storage, and networking. Then there's Platform as a Service, or PaaS, where they provide developers with ready-to-go environments to rapidly build apps without ever worrying about the underlying operating systems. And finally, with Software as a Service, or SaaS, they manage the delivery of fully baked online applications. It is a complete 100% abstraction from the hardware layer. But here is the catch. Because cloud resources are technically infinite, but business budgets absolutely are not, a massive part of a cloud engineer's job revolves around cost optimization. They frequently embrace a practice called FinOps and establish what's known as a Cloud Center of Excellence. This is a dedicated, cross-functional team that monitors cloud spending in real time, optimizes usage, and basically makes sure that the sheer ease of spinning up virtual machines doesn't lead to a totally heart-stopping bill at the end of the month. Section 4. Tools of the Trade. Command line versus dashboards. So when we put them side by side, the operational and conceptual differences on a day-to-day basis are just staggering. The network engineer is totally grounded in the physical reality of cabling, utilizing the Cisco iOS command line interface, dealing with port security, subnetting, and physically routing packets. The cloud engineer, on the flip side, lives in a world of APIs and web-based dashboards. They manage virtualization, focus heavily on FinOps to track cloud spend, and navigate the architectural nuances of IaaS and PaaS. One builds the physical road, the other builds the virtual cities sitting right on top of it. Section 5. Uniting in hybrid cloud, the convergence. So, what happens when a company wants the physical security and control of an on-premises network, but they also want the massive dynamic scalability of the public cloud? Well, we have to look at concepts like data sovereignty. This is the legal requirement that sensitive data must remain subject to the laws of the nation where it is physically stored, which means the real world isn't just an either-or scenario. A financial institution, for example, often has to keep its sensitive customer data locked down on physical on-premises servers managed by the network engineer, while simultaneously pushing its high-volume, everyday web traffic to the public cloud managed by the cloud engineer. This kind of regulatory and performance reality necessitates some incredibly complex architectures. A hybrid cloud leverages both private and public infrastructure to nail security and compliance, but it introduces huge management complexity. On the other hand, a multi-cloud strategy uses multiple public providers to avoid vendor lock-in, but that increases resource overhead. In either scenario, the network engineer and the cloud engineer have to collaborate closely to ensure traffic routes seamlessly, securely, and efficiently between the physical hardware and the virtual environments. To actually unite their powers successfully, both engineers have to execute a shared game plan when crafting an infrastructure strategy. First, they need standardized governance and security policies across both environments. Second, they have to leverage centralized cloud management platforms just to gain visibility into the chaos. Third, they must continuously track usage metrics to optimize cost and performance. And above all, they have to design for flexibility, ensuring that legacy on-premises systems can actually integrate safely with modern virtual architectures. We've seen how the network engineer lays the physical groundwork and the cloud engineer builds the virtual heights. But with hybrid models demanding their constant collaboration, the lines between these roles are blurring faster than ever. So I'll leave you with this provocative thought. As networking infrastructure increasingly becomes virtualized and managed entirely as code, will the distinct roles of the physical network engineer and the cloud engineer eventually merge into a single, omnipotent architect? It is a fascinating evolution to watch. Thanks for joining this explainer, and keep exploring the incredible architecture that powers our digital lives.